The second part of this amazing puzzle is the lithology, the rocks. These type of rocks are called travertine. Travertine is a form of calcium carbonate rock, so it's a carbonate rock. It is formed when it precipitates out of water that's saturated with calcium carbonate. How does it do that? It does it in three ways. One, it can precipitate out because it's saturated. Two, it can precipitate out because the pressure changes. And three, it can precipitate out because the pH changes. It goes up. But we're going to concentrate on it precipitating out when it becomes saturated. So the groundwater comes out, and it is saturated with this calcium carbonate. And it reaches the surface, and it starts evaporating. It forms even better and faster if it's a hot springs because it's evaporating faster. We have very hard water here in the Southwest. It's full of minerals, like all water is, all natural water. And if you want to think about sedimentary rocks precipitating out, think of making a glass of Kool-Aid. You put the Kool-Aid powder in, you put the sugar in, you stir it up. It dissolves. If you sat that glass out in the sun and let it evaporate out, the sugar and the powder would eventually precipitate out of the bottom because there isn't enough water to hold it anymore. So that's the basic idea. This is coming to the surface after being underground for a long time. The pH changes, the pressure changes, and mostly as it's evaporating, it's getting supersaturated. And it precipitates out and forms this kind of calcium carbonate rock called travertine. There's also a microbial component, so biology comes in here too. It forms at a rate of 1 to 3 millimeters a year, and we've got 2,000 feet of it here. So it's been around for quite a while. 2,000 feet of travertine here making the Montezuma well.